Welcome everyone. Welcome to this session. Very warm greetings from Mercy Technologies. So we've been coding on linked list since last 3-4 days, right? So let's continue coding on linked list and solve a bit more interesting interview problems today, right? These are interview problems which are asked in most of the product based company interviews, right? So this seemed to be tough, but today let's make them easy and try to understand how do we solve them, right? These are the problems that we are going to solve today. How do we find the middle element of a linked list? How do we check if the linked list is a circular linked list or not? How do we identify if there is any cycle that is there in the linked list? And one more thing I'll be doing today is I'll be introducing you to one more platform, which is LeetCode. Till now, we have done that in HackerRank. So there is Hacker Earth. I'll be introducing that to you later. And there is one more platform, which is LeetCode. The reason every platform does the same thing, guys. They'll ask you a problem, they want you to code, and finally they'll validate your program against the input or against the test cases they have. But I'm introducing you to one more platform so that you may become clear, because there are few companies who conduct LeetCode tests, right? And one more thing is we'll be seeing about a interesting question, which is an intersection point in the linked list. And now we'll be doing time and space complexity analysis to all the problems that we have done till now, okay, till date. So if I'm not wrong, the problems that we have solved till now are straightforward problems. The moment you see them, it should be coming into your mind, okay, the time complexity for this will be this, the space complexity for this will be this. So maybe we did not discuss that as part of the class, but with the basis or with the foundation that you got, you should be in a position to calculate that. But from now, I'll make sure that we are calculating time and space complexity for every program that we are writing. Okay, so let's straight away go and see the first program for today, right? What is that? Let's start coding. Let's go to our Eclipse and start coding. So what is it? Yeah. So our first program I told you is the first program that I told you is I need to find the middle element of the linked list. Let me not show you the code, but let me open the whiteboard. Okay. So what happens? Let's say there is a small input, right? Let's say there is a small input for us. There is an input. I'm taking that as part of my 28, 27, 26, 25, 24. Okay. So 28. So what is I'm taking the input just now, guys. So what is this? 28, 27, 26, 24, 25, 24, right? This is the input. This is the input, right? So here, this is marking the start of the linked list, which is head. So I'm having the pointers, right? And then there is null, right? Right? And then there is null. So this is the input of our linked list. So just by seeing this, what I want is, what is the middle of the linked list? I mean, this is just by seeing, what we understand is the middle of the linked list would be 26, right? Would be 26. The reason why it is 26 is there are two elements to the left side of it. There are two elements to the right side of it. The total length 1, 2, 3, 4, 5. Total length is what? 5, right? So what will the middle of the linked list? The middle of the linked list will be 5 divided by 2. So what is that? 2. So with the index starting from 0, 1, 2, 3, 4, the length of the linked list is 5. The maximum index of the linked list is 4. What is the middle element of the linked list? The middle element of the linked list will be 2, right? The middle element of the linked list will be 2 of the index 2, right? Of the index 2. So let's try to see small examples. We need to write code for this right now. We need to write code for this. So for that, let's try to take small examples. So we need to first identify our base cases. I've been teaching the same thing to you. Any program that you write, you need to identify the base cases, right? So what will be the base case? If So this is a base case. When the head is null, what will be the middle of the linked list? The middle element of the linked list will be null, right? This will be one base case. Second thing is, let's say our linked list is having only one element. Okay, if head dot next null, it is having only one element. So what is our middle of the linked list? The middle of the linked list will be the same, which means it has only a single element, which means only 28, let's say, only 28, let's say. So what will be the middle of that? It will be 28 only. What do you say? Return head, right? So what is our third base case? Let's say there are only two elements, 28 and 27. 28 and 27. What is the middle of the linked list? What is the middle of the linked list? Maybe, let's say, let's put a question mark to it. Okay, because we are not able to identify exactly what is the middle, because it can be 28 or 27, right? It has only two elements. Let's try to take even more examples now. Let's try to take even more example. I'm taking a fourth case, which is it is having three elements, let's say. So it is having three elements, 28, 27, and 26. So when the number of elements is 6, what will be the middle? So it will be length divided by 2, right? When you said length divided by 2, it is having 0th index, it is having first index, second index. So the answer 3 by 2, which means 3 by 2, what is the answer? It is 1. So which means our middle will be 27, right? 27 in our case. Now let's go to our fifth example, right? Let's say there are only 4 elements, right? Let's say there are only 4 elements. So what will be the middle of the linked list, right? It is an odd number. If you see, it is an odd number, right? It is an odd number. The length is an odd number. When the length is odd number, you are straight away saying length divided by 2, and you are getting the middle element of the linked list. But when it is an even number, the middle can be either 27 or 26, right? Middle can be either 27 or 26, because let's say 28, 27, 26, 25. This is the length. This is the total linked list we have at present. We are taking 4 elements. The middle can be 27 or 26. Now it's a time for you to ask the interviewer, sir, in case of even numbers, I can take the middle can either be 27 or 26. What do you want me to take? Right? You need to ask him, what do you want me to take? So he will say, okay, fine, you take 26 as the middle element, right? You take 26 as the middle element, or he says 27 as the middle element, whatever. Based on his input, we need to formulate our equation. When we say length by 2, even when it is an even number. So let's say 4 by 2, which is 2. So let's say the interviewer is saying that take 26 as the middle element. So which you say, you will be formulating it as n by 2, which is 26, right? It is even. So, but let's say the interviewer is saying, no, take 25, take 27 as the middle element. Do not take 26 as the middle element. So at that time, what you have to do, you have to formulate something like this: n by 2 minus 1, which is 25, right? The total length by 2 minus 1. This is how you have to calculate the index. So you have two options here. This you have to take. Guys, I think there was a network drop. Are you able to see now? Are you able to see? Are you able to hear me properly? Are you able to hear me properly and see my screen? Please reply. Okay, guys. So what I have been discussing, let me repeat that again. So we are trying to find out the base cases. We have an input something like this. We have input something like this. We are trying to find out the base cases. When the head is null, we are returning null. When it is having only a single element, which means a single node, we are returning the same node. When the third, which means it is having three elements, which is it is having only two, the length of the linked list will become an even number. So in that case, we need to ask the interviewer is what we have said. So let's go to the next step, which is 26. 26, the middle element which straight away will become 27. So what is the formula that we have given? The formula that is given is n by 2. And then we are coming to 25. The length of the linked list is 28, 27, 26, 25, which is 4. So what you're trying to do, you'll be asking the interviewer, sir, should I take the middle element of the linked list as 27 or 26? Let's say he says 27. Your formula will become n by 2 minus 1. Or let's say he's saying 26, your formula will become n by 2, right? So in even cases, the input can be, or the formula that we can formulate could be n by 2 or n by 2 minus 1. So let's try to fill up the third one that we have left. So what is that? N by 2 minus 1. So what is it saying? N by 2 minus 1. In this case, the length could be 28 and 27, which is 2 by 2 minus 1. So it can be either 0, which means it is saying either 28. So based on this formula, our middle term linked list will become 28. Or else, if the input, if based on the interviewer's input, let's say you're taking n by 2, which is 2 by 2, so which becomes the index is 1, and that becomes the middle can be 27, right? These are the base cases. This is the basic understanding that we need to have before we start writing the code. Anytime interviewer asks you to write code, you have to formalize everything in your mind. This is called as thinking loudly. Okay, so you need to formulate all the base cases, you need to write them aside, or maybe you need to get some full clarity on what is the code that you're trying to write. So after you get clarity on all the base cases, and after you try to get clarity on this confusing cases where the length can be an even, so what should I take in that case? What should I take in the odd case? What happens when only a single element is present? So in these cases, you'll be asking the interviewer and you'll be getting clarity. This is very important because interviewer expects this question. No interviewer will ask you or wants you to write code straight away. There is a problem, okay, fine, I'll start writing the code. It's not like that. It's never like that, guys. You need to ask questions, and interviewer should feel that you're asking the right questions, and after he feels, you need to write the code following the standards, following the golden rules that I told you previously. Let's try to write the same. It's a very simple code, right? Very simple code. So I'm trying to do the same thing here. So what is the first step? I'm trying to say base case number 1. Head is equal to null. What you're trying to do? You're trying to return null. Right? It is when the head is null, which means there is no linked list that is existing. Now let's try to go to the second one. What is that? Head dot next is equal to null. In this case, only a single element is present in our linked list. So when a single element is present in that linked list, in our linked list, which is 28, we are returning the same element, right? We are returning the same. So I told you we should never modify anything on the head. So I've taken a reference variable of p and assigning that to head, right? Assigning that to head. So if you remember, we have solved a previous problem, which is saying get length of the linked list. This is the previous program that we have written. So this is the code for that. I'm not going deep into this right now. So what this code does is, as we have written in our previous class, it's the length, right? It will be giving us the length. So when this code gives us the length, what we have to do, we have to find out, we have to formulate a formula. We have to write a formula. So what is the formula for that? I'm thinking the interviewer has guided me to take the n by 2 formula. So what I'm trying to do, I'm trying to do length by 2. So I'm taking a count called 0, and I'm having a loop over here while count is less than middle. So I'm incrementing that and finally returning p. I'll be dry running this code, but just by taking this example, 28, 27, 26, 25, 24. So let me try to run this code for you. So what is this saying? This is saying the following. What will be the middle? The middle element will be 26. Let's say the middle element is 26. The reason why it is 26 is we are taking n by 2 formula, right? N by 2 formula. But say interviewer is asking us to take a formula something like this, right? Interviewer is asking us to take a formula something like this. Oops. something like this. I'm formulating it like this and finally saying index of this -1, right? -1. So let me try to run this program for you. It should be giving me a different output, right? It should be giving me a different output. What is given? It is giving 27. So what is 27? 27 is the previous element, right? So this is how we have to write the code. Let me try to dry run this code for you and make you understand what exactly it is. I'm taking a screenshot for this. Just a second. Right. So here is our code. Here is our code. I'm copying this and putting that in the whiteboard. Or maybe I'll use the same thing. Let me try to do that. Just a second. Okay. So this is our program. So what is our input? 28, 27, 26, 25, 24. Right? I'm straight away writing those. 28, 27, 26, 25, 24. So this is our input. What is this pointing to? This is pointing to null, and this is pointing to head, right? So we are saying as line number 5, we are asking if head is equal to null, return null. Head is equal to null? No, it is pointing to 28. So this case will not be occurred. So we are checking if it is having only one element. If head dot next is equal to null. What is head dot next? It is 27. Is 27 null? No. So this case also will not be occurring. So at that time, what you're trying to do as line number 11, you are saying node p is equal to head. Let's say I've taken a variable, a reference variable called p, and I'm saying p is pointing to this head, right? What you're trying to do as part of this, you're taking a variable called length and you're trying to find out the length. So let me say length. So what is the length? 1, 2, 3, 4, 5. So 5 is our length. That's fine. So we got it as part of line number 12. And what you're trying to do, we have one more variable, which is middle. So what is middle saying? Middle is saying length by 2 minus 1 in our case. What is 5? 5 by 2 minus 1, which is 2 minus 1, which is 1, right? This is how you got middle. Now again, you're having one more thing, which is count, right? Let's say we have something like this, count. So what you're trying to do, the count, the value is 0, right? Initially the value is 0. So you are going to line number 15 and you're trying to iterate over this. While count is less than middle, what is the count's value? 0, and it is less than 1. That's fine. So what you're trying to do, this condition, and it's coming inside p is equal to p dot next. So what is p now? P is equal to this one, right? P is equal to p dot next, and you are incrementing count. So here the count will become 1, right? So again, it's coming back to line number 15. While count is less than middle, what is count? Count is 1. What is middle? Middle is also equal to 1. It's not less, it's equal, right? So which means this is now gone. And now what you're trying to do, you're trying to return P. So what is P? P is 27. So that is what our expectation is also. That is our expectation is also, and our output will become 27, right? So this is very simple. This is a very simple code, and this is how we are trying to find out the middle element of the linked list. Now what is our actual thing? As part of our agenda, I told you we'll be calculating the time and space complexity for this. So let's try to see what is the time complexity. The time complexity here, we have to analyze only this part of this code, only this part of the code. Let's try to understand, is there any time complexity in this? No. Is there any time complexity in this? No. Is there anything in this? Nothing, because there is no loop, there's no increment, nothing here. But here, if you see linked list or get linked list length, right? Get linked list length. What is the time complexity of this particular program? Let's try to understand. Okay, get length of the linked list. This method, what it is trying to do, it is trying to do this. Here also there is no time complexity, but there is a loop here. It can be a for loop or a while loop. It is iterating how many number of times? It is iterating that many number of times as directly proportional to the length of the linked list. So which means if the length is 100, it is trying to iterate for 100 times. If the length is 10,000, it is trying to iterate for 10,000, which means it is directly increasing as part of number of input that you are giving. So which means the time complexity as per our previous theory, the time complexity will become order of n, right? What will be the space complexity? The space complexity will be order of, okay, there is one more part, guys. We have not analyzed the total program here. Okay, this part, only this line is giving us order of n time complexity. So we have come down, this is having no time complexity, this is having no time complexity, but here if you see, we have one more while loop, right? Which is one more loop we are having. So how many times we are iterating? Here in our case, we are iterating n by 2 number of times, right? Let's say the input size is 1000, right? First you will be iterating 1000 times to find out the length of the linked list, and finally as part of this loop you will be iterating that by n by 2 minus 1, which is n by 2 times, which is 500 times. So how many steps it would become? 1000 plus 500. Okay, so it is 1500. So what we can do, we can say the time complexity is order of n plus order of n by 2. So I told you this is a constant. We need to ignore that. We need to ignore this. So again, it becomes order of n plus order of n, which let's say is order of 2n. Right. Again, this is a constant. Again, 2 is again a constant. So what we have to do? Order of n is our time complexity. But even though the time complexity is order of n, what we need to understand over here is, even though the time complexity is order of n, we have to understand that, let's say the input is 1000, we are taking 1500 steps, 1500 steps. So that 500 is an ignorable factor as per our time complexity and space complexity analysis, right? So that's why the time complexity will become order of n, right? This is just our basic understanding. At this point, I just want to cross check if everyone understood this or not. Guys, at this particular point, I just want to say, to find out the middle element of the linked list, let's say the input is 1000, you are consuming 1500 steps, right? You are consuming 1500 steps. Let's say the input is 50,000, you are consuming 50,000 plus 25,000, which means 75,000 steps, right? 75,000 iterations. Now this is called as a brute force way of calculating something. What is brute force? Brute force is just a term. Like for example, let's say you are giving some task to a guy who's not a professional, right? Some task to a guy who is not that keen in programming, or the person who just started programming, or the person who has not analyzed the problem well. So when you're trying to give something to a person and he's coming up with a solution, and that works, right? And the solution works without putting so much of brain into it, and solution works without having done actual analysis, just by an intuitive opinion. Like somebody gives you a problem and you say we can do it in this way. So that is called as a brute force approach. So let's say somebody is asking you to find the middle element of the linked list. You are giving you this problem. It works, no problem. But here, this is called a brute force way of calculating something, which means it's a straightforward way, which means you are writing the program that may not be used by professionals, right? The reason is just to calculate, or just to find out the middle element of that linked list, how many times you are iterating. You are having two loops in your small piece of code, from line number 4 until line number 19 until line number 20. You are having two loops in the same method. So which means you are consuming almost 2 times of the length of the linked list, right? So interviewer asks you, can you do it in a better way, right? Can you do it in a better way? So this is the question. So let's try to understand what would be the other approach that we can give, so that we can improve the time complexity. Here the time complexity is order of n, but if we dig deep into the concept, we are taking n plus n by 2 number of steps, right? So interviewer will ask you, can you do it in a better way? Then the next question is like, what should I improve? Should I improve the time complexity or space complexity? The space complexity here is order of 1. You can never improve that, because your input size is not increasing So based on our input, right? So which means space complexity is perfect, which means he wants you to improve the time complexity, but you're saying the time complexity is already order of n. What else can I do? So even though it is already order of n, you're taking n plus n by 2 number of steps. So what you have to do, let's say we have to reduce the number of steps. Now let me introduce you to a new concept in solving the linked list problems. This is the most common concept that is used to solve any medium or tough interview question in linked list. So what is that concept called? It is called as the concept of fast, the slow pointer, and fast pointer. So this is a concept called slow pointer and a fast pointer. Slow pointer and a fast pointer. What is slow pointer doing? Slow pointer will move one step. So it moves one step ahead, moves. So what is fast pointer doing? It moves two steps. It moves two steps ahead. Right? So for every iteration, let's say your fast pointer is moving 2 times, your slow pointer will be moving only 1 time. Let me show you the code. Let me show you the code of using slow and fast pointer, and let's try to analyze how we are trying to improve the solution that we have initially given. How we are trying to find out if our brute forces can be improved, right? So this is middle element of the linked list. This is one more example that I have written. So this is the code that I've written, guys. So what am I trying to do? I'll be having the same base condition. If head is equal to null, I'm returning null, right? Head is equal to null, I'm returning null. I've taken 2 pointers, which is P and Q. The first one is called as a slow pointer. The second one is called as a fast pointer, right? Here I'm trying to write this while loop. We'll be dry running this code and I'll be showing you what exactly it is. But here I'm trying to write this single loop. There are no 2 loops. Here initially we have 2 loops here, right? This is one loop. If we go inside this method, this is one loop and this is one more loop here. But in the second approach, I'm having only one loop. And by using slow and fast pointer, I'm trying to achieve what is the middle element of the linked list. So just by this code, for example, let's say I'm having 28, 27, 26, 25, 24 is the input. And let me try to run this code for you and make you understand. So our output would be 26, right? Our output would be 26, right? So at this particular point, what I want to say is we are solving our problem just by using a single loop, and we are able to find that the middle element is 26 in our case. Let me try to dry run this code for you and make you understand what exactly it is. Okay. I'm copying it. Sorry. I'm copying this. Okay. So here we'll be doing that on whiteboard again. Okay. This is the code that we have written. So using this code, let me try to do line by line. So what am I trying to do? As part of line number 5, head is equal to null. But our head, let's say our input is something like this: 27, 26, 25, 24, 23. I did not start with 27, 28, but that's fine. It is just our example input. And here we are pointing that to null, right? This is head. So what we are trying to do, we are checking if head is equal to null. This is not coming. This case is not coming. So which means we are not coming into this case. So what am I trying to do? I'm initializing 2 pointers P and Q. Here there's a pointer called P, and then there is a pointer called Q. Right? There are 2 pointers P and Q. So what we are trying to do, we are saying we are calculating while Q dot next is not equal to null, Q is not equal to null, and Q dot next is not equal to null. So I'm checking that. What is Q? Q is 27, and Q dot next is what? It is 26. So both are null, not null. So that's why it is coming to this part. So what are we trying to do as part of this part? P is equal to P dot next. So we are moving P by 1 point. So this is P now. And what we are trying to do as part of line number 11, we are saying q is equal to q dot next dot next. So what is q? Next dot next. Now q will become this, right? Q will become this, correct? Q will become this. So again we are checking as part of line number 9, again it's coming back, q is not equal to null, q dot next is not equal to null. So what is q here? Q is this, q dot next is this. So both are not equal to null. So we are coming into line number 10. We are saying p is equal to p dot next. So now the p's value is this, p's value is this, p's value is this, and q is equal to q dot next dot next. What is this? Q is not this, q is equal to q dot next dot next. Q is here, right? Q is here. Again, we are checking as part of line number 9. Q is not equal to null. Yes, Q is not equal to null, but Q dot next is not equal to null. No, Q dot next. What is Q dot next? Q dot next is this. What is this? This is null, right? So that's why this loop is breaking and it's coming out. So what we are trying to return? We are trying to return P. So what is P? P is 25, right? So if we observe, P is at 25, but what is P is at? It is at the middle element. So the middle element is 25. So in this way, what you're trying to achieve, you are trying to achieve the middle element of the linked list just by, just a second. Okay, so the middle element of the linked list just by using this approach. So in this way, you are not only doing that in single loop, but you are trying to do that by giving how many, by taking how many steps? You are taking n by 2 steps, right? N by 2 steps, which means, let's say the length of your linked list is 100. Length of the linked list is 100. You are trying to do the same thing because you are trying to increment q by 2 times. You're trying to do the same thing by how many iterations? You're trying to do that by 50 iterations, right? In the 50 iterations, let's say the input length is 1000. You're able to do that in 500 iterations. In our previous approach, we were taking 1000 plus 500. So what is that? 1500 steps. But using this approach, we are able to do that in only 500 steps. So in that way, your time complexity will be reducing to how much? It will be reducing to order of n by 2. But I told you 2 is an ignorable factor, so which means order of n. Again, the time complexity is order of n only, but here the thing is you are able to do that only in single loop, first thing, and you are able to do that in n by 2 steps, right? In this way, you are able to find out the middle of the linked list, right? This is a 2-pointer solution, and you can apply this solution to most of the linked list problems. Let's say whenever interviewer asks you to, how do you improve this solution? Can you write a better approach for this solution? Can you reduce that to a single loop, etc.? This kind of questions. The thing that should come into your mind is, I'll be using a 2-pointer solution. When you use a 2-pointer solution to most of the linked list problems, you will be doing that in a very good, I mean, in the best possible way, right? So at this point, guys, I was able to dry run this code and make you understand how exactly we are solving. Let's see if everyone has understood this problem. Please reply. So what we have done till now is, we have done one thing. We saw a better approach of doing something, right? A better approach. Till now we have done that in a brute force way, just by finding out the length and saying that this is what it is consuming, etc., etc., right? But with the 2-pointer solution, what am I trying to teach you? I'm trying to teach you one thing, which is slow pointer moves only 1 step and fast pointer moves 2 steps. So by using this approach, you're trying to reduce the number of iterations only by 1, and you're trying to reduce the number of steps, right? You're trying to reduce the number of steps. Now, what was our agenda for today? Agenda for today was, we'll be finding the middle element of linked list. We came up with 2 solutions. First thing is a brute force solution, where you're trying to find out the middle element of linked list by calculating the length. And second is using 2-pointer solution. Now we'll be writing one more code. It is one more interesting interview question, right? Is our linked list a circular linked list or not? Is our linked list a circular linked list or not? So what is a circular linked list? Let me explain that to you again on the whiteboard. So what is a circular linked list? Circular linked list is nothing but there is no end to this linked list. For example, something like this, I've taken an example like this: 1, right, 2, 3, and 4, right? So I have taken a linked list something like this, right? And instead of pointing this to null, so this will not point to null, but instead it again points to the start, right? So this is a head, right? So in this way, there is no end to this linked list. So it is like a circle. It is like a circle, right? It is like a circle. So how do you find, for example, let's say interviewer has given, I'm giving you the head of the linked list. Okay, I'm giving you the head of the linked list, and tell me if it is a circular linked list or not. This is one more important interview question, right? Just tell me if this is a circular linked list or not. So how do you find out? You find out using the same concept. You find out using the similar concept. So there will be two pointers which will be fast pointer, and then a slow pointer. Using the same concept, you will be trying to solve this problem. I'll be showing the code straight away. So what is the code for that? Is circular, right? Is circular linked list. So what am I trying to do here? Here I'm checking. So again, we need to figure out the base cases. If the head is null, then it would never be a circular linked list. And one more thing, I'll be telling you about the method signature. Is circular is a method that you have written, and you have taken head as the input for that. So this method should say either the linked list is true, I mean, it is circular or not. So it will be returning true when it is circular. It will be returning false when it is not a circular linked list, right? So with this understanding, let's move forward. When head is equal to null, it is false, because when head is equal to null, it's not a circular linked list. When head dot next is equal to null, which means it is having only a single element, it will never be a circular linked list. And head dot next is null. Head dot next is null. Even in this case, it has two elements. So one second, it has two elements. So what are those two elements? These are the two elements, and it is saying head dot next is null. So instead, here we are checking if it is null or not. So in this case also, since it is having only two elements, so we are concluding that it is false in that case also. It's not circular when it is having two elements also. So at this point, what am I trying to do? I'm taking pointers p and q, which is a slow pointer and a fast pointer. I'm having a while loop something like this. While q is not equal to null, q dot not next is not equal to null. I'm moving this two times, and I'm checking if p is equal to q, then return true, right? Let me try to dry run this code for you and make you understand how do you detect if it is a circular linked list or not, right? So I will be taking a screenshot for this. Right? Let me paste that and make you understand. Make you understand what we are actually trying to achieve, right? Maybe I'll be doing somewhere over. So here it is. Here is our code. Okay, so here is our code. What is our code saying? Our code is saying that this case will never occur because the base cases are not there as part of our example. Here you are taking p and q, and those are fast and slow pointers. What is p? The p is something like this. It is initiated to head, and you are taking q. Again, q is also initiated to head. These are the two pointers, right? So again, what you're trying to check, if q is not equal to null, q dot next is not equal to null. Q is not null, q dot next is not null. So you're coming into line number 11. What is line number 11 saying? Increment p by one pointer. So here p will be over here, right? P will be over here. And now, as part of line number 12, you're saying q dot next. What is q? Q dot next, right? Q is now not here, but it is next. It is here, right? It is here. Q is over here. Now, again, what you're trying to do, you're trying to do one more thing. If p is equal to q, both p and q are equal. No, p is not equal to q. The reason why it is not equal to q is this both are two different nodes. What you're trying to do, you're in this it's not coming. So in this case it's not coming. You are again coming back to the loop. While q is not equal to null, q dot next is not equal to null. Q is this and q dot next is this both are not equal to null. So you are coming back to line number 11 and saying p is equal to p dot next. What is P now? P is now over here, and Q is incrementing 2 times, right? Q is not this, but Q is what? Q is this. Q dot next, right? Here it is Q right now. So again, you're checking Q is equal to P. No way, it's not. So again, you're coming back. Again, you're coming. What you're trying to do? P is equal to P dot next. Our P is over here somewhere. P is equal to P dot next. P is equal to P dot next. Our P is somewhere over here, right? And Q is equal to Q dot next dot next, right? Here Q is not this, but it is 1, 2. Q is over here right now. Q is over here right now. Again, you're trying to do, if Q is equal to null, Q dot next is not equal to null. No. So what you're trying to do as part of line number 11, you're saying P is equal to P dot next. What is P? Now P is over here, right? Again, what you're saying, Q is equal to Q dot next dot next. What is Q? Q is not this, next dot next, right? Q is again this. You are checking if P is equal to Q. In our case, what we are trying to see, P is equal to Q, right? Both P and Q are there. So it means you are returning true. You are returning true, right? Which means you are returning true. Fine. So in this case, we have detected that there is a circle, there is a cycle, and so we are saying that it is a circular linked list. So in this way, you are able to achieve that. You are able to see if the linked list that you have given as an input is circular or not, right? This is one more important interview question, guys. Are you able to follow me in this? Okay, thank you for the replies. So now what I'm trying to say is we have done one more part. We have done one more part, right? We have achieved one more problem and try to find out if the linked list which is given to us as an input is circular or not. So let's go back to our agenda for today. Our agenda for today is saying one more problem, which is cycle detection. Guys, we are taking so much of time today, but I will be ending up our today's session by cycle detection. Let's move forward to the next tomorrow. The cycle detection will take less than 5 minutes, so please concentrate. So what is cycle detection saying? Cycle detection problem is also similar thing, right? I'll be showing you one example, right? Here I have taken one HackerRank problem. So what is it trying to do? It is trying to say that a linked list may be something like this, and it can have a cycle something like this, right? It's not circular. 3 is not coming back to 1, but it is having some cycle, right? It is having some cycle. Our intention is to find out if cycle exists in it or not. Cycle exists in it or not. Before that, let me try to run this code for you. Is circular linked list. What is a circular linked list saying? I'm saying I have initialized 28 until 24, and I'm saying 24.next is equal to 28, right? I'm pointing the last the tail node again to the head node. What is our head? Head is this. So with this, let me try to run this code for you and make you understand that it is returning true for us. It's returning true for only one reason. The reason is it is a circular linked list. Let me tell you one more thing. Even for identifying if there is a loop that is existing in the linked list or not, if there is a cycle that is existing in the linked list or not, you will be using the same approach. You'll be using the same approach. What did I do? I've taken the same code. I copied the same code, right? I've taken the same code. Maybe I tried to modify, instead of node, I tried to modify that as single linked list node. I copied the same code here, right? Here, what am I trying to do? I'm trying to see this is the base condition, right? So these are the two fast and slow pointers. I'm having a while loop. I'm trying to improve or increment the fast pointer by 2 times, checking if P is equal to Q. If in that case, return true. If not, return false. I'm doing the same thing. I did the same thing. Let me run this code for you. Okay. So what it says, we are able to see that it is passing, right? So what I want to emphasize over here is there are two problems. One is to find out if it is a circular linked list or not. Second is to find out if there is a loop that is existing or not. In both our cases, we are able to use the same code, right? In both our cases, we are able to use the same code. I don't know, it's taking time. Okay. So in this case, we have achieved in such a way that we are able to use the same code
to solve two different problems. The reason is we have an idea on fast and slow pointer. So same thing, guys, happens to similar problems or most of the problems. Any problem that's given to you, first you need to try to find out, okay, this is a linked list problem. Let me try to check if I can apply this fast and slow pointer solution to this problem or not. If you are able to achieve that, if you are able to apply that, and if you are able to solve the problem, then done. Because in this way, you are able to solve many questions with a single concept, right? Guys, you are able to understand the cycle detection problem. We have used the same code. What you can do is you can take a similar example, something like this. You can dry run the same code, just like how I have done that with a sample input, right? With a sample input, and you will be in a position to understand that in a better way. Guys, at this point, I want to ask